let's have a look at what we are presenting here. It's the next kind of chapter in our release of CAS IP Finder. We had previous webinars where we showed the query builder, where we showed the exploratory search and the viewer with possibilities of also visualizing results. In this session, we will focus on the addition of CAS Newton for CAS IP Finder. What is CAS Newton? So that is our agentic AI that allows you to really get assistance during your STN searching. We have made a really deliberate choice to develop an AI agent that doesn't take over the task of doing a patent search or finding literature or doing kind of a landscape, but instead create one that becomes kind of your assistant in the sense of it helps you navigate through the STN content, the different databases, the search capabilities, and sometimes even selecting the right databases can be a challenge. Or if you know several really well, then what would be potentially other sources where your topic could also be explored? This would also provide kind of a full disclosure. So this would feel very little as a black box, but more where you have full transparency of what the AI agent does in generating or suggesting search strategy steps that will help you go through your question that you can ask in a natural language that is then translated into the various commands for STN. So that is what CAS Newton for CAS IP Finder aims to do. You may ask us, why did you come up with CAS Newton? I would not expect the name of a famous physicist to be used for, I don't know, mainly a chemistry related tool. And the reason for this is Newton had a fantastic quote, which I think applies here very well. He said, I can see farther by standing on the shoulder of giants, meaning all the scientists that had done work before him, and standing on those shoulders, he could see the next breakthrough in scientific discovery. And we felt that that was very much like you and your colleagues standing on shoulders of millions of publications in patents and other publications to see kind of what is there, what is the IP landscape, what is any relevant information that would support you in making R&D or IP decisions. So we wanted to have a closer look at how this tool actually works. Let's first take a look at where you would find it. And I would say if you have your STN settings very much set up so that you start in the query builder, then it's almost impossible to neglect it, because our colleagues have put this very nice banner at the center of the page, get started faster with CAS Newton. And there's the button highlighted here in red on my slide that allows you to start that search. The search can also be started by clicking on the Newton icon, which you see highlighted with the red circle on your menu. So at any point, if you want to start a fresh search with CAS Newton, then that is the button to go to. Also, if you start, for instance, your STN session not in the query builder, but with the command line, then you also have that same button here on the top left, or you have the promotional banner at the right bottom part of your screen that would also allow you to start a fresh CAS Newton search. So this functionality has been deployed to all of our customers that are under a, let's say, a flat rate contract. These are known as Global Value Plans or STN IP Protection Suite. If you're not sure what your contract with STN is, then please contact your account manager and they can help you further. So this functionality, maybe saying that upfront, is not available for people who have access on a transactional access basis. So if you like what you see here and you would like to know more, then again, it would be good to contact your account manager for STN. So we're going to have a good look at what are good use cases for IP Finder for CS Newton for IP Finder. And this is, as I mentioned, not designed to take over your task, but to help you navigate the search options and the content options in our platform. So identifying useful databases, navigating the search fields, the display formats available, work out an effective search strategy, and the LLM, the AI model, is trained basically on database documentation and also a growing collection of expert documentation sources. My team has provided a variety of training materials and presentations, and also our colleagues from IP Services, that's Matt McBride's team, and his colleagues both in Europe and in the US have provided further documentation that could help the LLM understand better the appropriate search strategies, proximity operators, display options, etc. So that's what it is trying to do. Maybe up front, before we take a look at it, maybe to set your expectation, what are we still working on? So what is not there at the moment is a possibility to make a combination of a structure query and, let's say, the free text to do that. This is something that is being worked on, and we expect that to be available within a few weeks. And then we're also the technical team is also working on additional search strategy recipes to train the LLM on specialized domains like formulations or bioactivity, sequences, and maybe also things like detailed legal status queries. And if you have particular wishes, or you say, I wish it was smarter doing this or that, then please contact us either through your account manager or through the help desk. We would absolutely be delighted to hear from you and work on further solutions that would make your life easier. So I have, together with my colleagues, arrived at 7 different use cases, starting fairly simple and then growing into a little bit more complexer cases. So we start pretty easy with verifying maybe an unusual patent number from India. Those are always very challenging in that case. But also we will look at a possibility of finding an exhaustive list of family members for a specific WO application in the 3 main larger databases, CA+, WPI, and Impadoc. We'll take a look at a chemistry search where we are looking for patents that describe the substance Dapsone, which has to be used as a catalyst. And then also our 4th project is about identifying the most common substances that are part of the PFAS, the perfluoro and polyfluoro alkyl compounds that have an impact on the environment. And then develop a search hedge for a strategy on vegan meat. We'll take a close look at, or maybe just a superficial look at, a numeric property search. We'll actually have a coffee lecture that will go into a lot more detail in a few weeks there as well. And then my final one is on trying to identify emerging drug companies in a particular country, in this case in Turkey. So we will have a look at that. If we would do all of these live in front of you, then we'd be looking at, I don't know, a screen that is still very active in the background, but it's not very exciting for you to look at. So instead of a live presentation, then we will show you a recording of those sessions, of those use cases, where we cut out the waiting time so that we can have a better view of that. So I'm going to switch my background here to look at the webinar and to the video, and we will get this started. So I think I am going to, if I should press the play button, we should also hear it. Maybe if one of my colleagues, Mike and Rob, if you could confirm that you can hear the audio as well, then that will be fine.
So let's have our first project. We're going to move to the CAS Newton button here in IP Finder, and I'm going to paste in my query, and we're going to have a look at what this is going to provide. This is already fine. It starts in the India full text database, IN full. It's going to try this search to find what it is doing, and here it already found an answer by providing the IN before that, and we see that it was able to find this in the APO field, which is the original application field, which I know we probably would not have assumed that that was the correct format in which we would have found this. So here we do see that, for instance, in the original patent number, the second M is dropped. However, in the original application fields, that is still kept. So we were able to find the correct patent and very quickly, and that probably would have saved us quite a bit of time in trying different things and seeing how that format should have been done. So it provides us a little bit further information on the inventors, the classification codes, the abstract, etc. So very nice way of providing this information. Let's take another look at a new question. By the way, you do have the possibility to download this. The download will give you an option, either RTF or PDF, both for the conversation and then also the command line transcript. The other thing that is worthwhile to remember is that here I have the possibility to enter an STN command, just if I'm familiar with that, or I can ask a subsequent Newton question. I also have the full search in my history. So if I go to the command line and I would give the command display history, we would see that all of those capabilities, those two search steps are there, and my answer is also there. So if I want to do anything more with that, for instance, take this to the viewer, then those are very fine things to do after CAS Newton has provided you your original request. So let's look at another feature. When you submit a new question, this is also pretty significant. So if I give my next question in the background, automatically CAS Newton is going to do a delete history and confirm that, and delete select. So please do not use Newton as a follow-up step of an existing search strategy, because you would lose all your manually entered text. So that is not helpful. So let's have a look. I have another question here. I'm interested in finding a comprehensive set of all family members of this WO patent publication. So let's see what it is doing. It's considering which databases that would work out. So it decided to go to the IMPAFAMDB database. That's a good choice. And it searches the WO. It's considering a family display. And here we see that we find already a number of these patents. It's deciding now also to look for legal status information and some further details. By the way, there is a stop button here if you feel that CAS Newton is going off in a tangent that you were not really interested in, you want to intervene, then please just press that stop button, and we would be able to then come up with some further prompts. So here we see that it had found 3 priorities, 16 applications, different legal status events, 1 EPO simple family. So we get some additional information around the status indicator. That also looks fine. But here I would really like to see if there would be, let's say, more information from the CA Plus and Derwent database. So my next subsequent questions is, please also check CA Plus and WP Index for additional family members. Please create a table with country, patent number, publication date, application number, application date, and the database found. So let's have a look. I can certainly provide additional information that sets kind of the boundaries of what I'm expecting, maybe a specific format, a specific overview, and so it is going to run those searches here in CA Plus. Displays the information, going to WP Index. By the way, the typical positive encouragements like great, wonderful, they're kind of part of the charm of agentic AI. So take that in a positive, encouraging way. Hope you don't get too distracted or too annoyed with that. It's doing its best, and it uses quite a bit of self-congratulations, so to say, of things that it has found. Let's see what it did bring back. So we have a much bigger table now. So what did it find here? I found data from all 3 databases. Let me compile it in a comprehensive table. So I found additional family members that were not in IMPADOC, including Ecuador and these other countries. So here we can now see something which is similar to that expanded patent family report that we had a few years ago, where we can see the databases, where it comes from, the application date, application number, publication date, publication number, and the country. So that's a very nice overview. I can just copy and paste that, or just export my transcript, so to say. The final report is there. So instead of just manually having to, deduplicate the information that we find in these tables and deal with all types of different ways that this could be done, we can ask Newton to do this. By the way, here in the Derwent file, I do see that we have what is called a non-traditional equivalent or non-conventional equivalent. The hash here indicates that this is a family member that was added not based on priority information, but really more on the total coverage and content of that particular patent. So that's certainly a value add from the colleagues from Derwent. Well done. We are going to go to our third question, and that is looking at a little bit more of a chemistry scope. So I'm going to ask for a new question. Let's have a look. So in this case, we're interested in finding patents where the substance Dapsone is a catalyst. Consult all applicable databases that include substance roles for reactions. So I provided a little bit more context, and the background here is that I would like Newton to not only search CA+, but also search CAS React, because especially standard catalyst may not always be indexed in CA+, but they may, or they will always be indexed in CAS React, but not all reaction containing publications are selected for coverage in CAS React. So let's see what Newton is doing with this particular search. So it starts in registry. It is found that there is a specific substance by name, so it will search that compound by name, looks at the information. We see that there's a lot of trivial names and trade names available for this. We see that it has found a registry number, very easy to remember, 80080, and then it's going to go to CA+. It's going to link the catalyst role to the CS registry number, and it's also then going to add the patent as document type, because I did ask for patents, and then it has found 93 patents in CA+. Found some information there. Now also going to go to CAS React, which has more reaction information also from the patent literature. So there it also tries to search the registry number of that with the patent as the, and here it's using the PN number or the PN search field, which is actually not correct. The nice thing of CAS Newton is that the PN field is really just used for patent numbers, and so it has then recovered from that error and used patent as document type. And it has also found that it can do a more specific search by searching this with the catalyst role, which is also applicable in CAS React. And it found 14 different publications. Let's scroll a little bit further back up. So it's bringing the results from the two databases together. Let me create a comprehensive summary. So it did look for the registry number. Here we have the names and other names. 93 in CA+. So using this as the search strategy, a couple of the recent patents that are there, key features of CA+, which is helpful. And then CAS React, it found 14 answers there. And it did find some unique results here as well. So, and in that way, we can see that in those two databases, we can find that. So I have one more subsequent question for it to ask, and that's to see who are the owners or which organizations are behind these documents. So my question here is consolidate the results into a single database to analyze the ultimate owner field and the priority year. So let's see what it will do with that. It's consolidating within CA+, which is good. It combines the two L numbers. We see that we do indeed find 8 unique answers in CA+, or in CAS React that were not indexed with that substance as a catalyst in CA+. And now it's going to do an analyze both in ultimate owner standard as well as the priority year. And here it's actually using the tabulate command by trying to create a two-dimensional overview of this and at least searching for that information in the top answers for the ultimate owner as well as the other information that is there. It also gave us the priority years. Please keep in mind that these are obviously always 18 months behind the publication years. So, and then it looks at the geographic distribution, priority countries. And again, if you feel that this is beyond what you requested, you have the possibility to stop the process and not continue any further. So here we have then our nice summary. So we can also see kind of a table with the geographic distribution. and also with the ultimate owners. So that is there. We see some Japanese, some European companies, even some universities there. Again, the Chinese Academy of Sciences almost in all of those. So that looks pretty solid. Yep, very nice option here as well. So for our next project, we're going to give it some very specific instructions. Here we are interested in finding substances that are most commonly cited as PFAS. Provide a list in registry of the top 500 common PFAS substances. Focus on those that are obviously cited as PFAS in the affiliated documents. Omit substances that are commonly cited as drugs or therapeutics. And here I said, let's ensure the candidate list is correct before displaying further information. So I really want CAS Newton to verify with me, is this the correct list? Should we continue? And then maybe we want to make some adjustments before it starts to do a massive report on those 500. So let's see how this would work. Good. So while the documentation expert raises valid concerns about database limitations, so here we are going to go to CA+, and then look for perfluoro compounds, found a lot of those, taken out those that have a therapeutic or biological approach. It was then trying to select a large number, which is obviously not possible. So it has extracted 999 unique registry numbers from the first 832 PFAS-related documents. Okay, so it has transferred all those 999 compounds. It then tries to search left and right hand truncation in the chemical name field. That is obviously not working, but it corrects itself. Say, I can search this in the chemical name segment field, and then found at least 363 fluorinated substances. So that is there. So it's going to search perfluoro in registry. Going to CA+, this is also an interesting approach, and going to combine those perfluoro compounds with that. It is obviously not helpful to do perfluoroalkyl because that would not be a relevant search term for registry. Registry would only have specific substances, so you would have to do octyl or nonyl or decyl or larger alkyl chains like that, but at least it has given some suggestions. It was doing the analyze command on 2000 records, lots of different substances. So, and then it combines it back into registry with compounds that at least have fluoro. Yeah, perfluoro. Yeah. So that looks at least quite useful. Okay, so it indicates that after some back and forth, it has found, close to 500, 486 fluorinated substances that are commonly cited as PFAS. And if we look at our list, this looks pretty decent. Pentafluoro, so not everything has perfluoro as a name, so I think I am happy with that. Refining this to perfluoro would have been too narrow. We would have missed a number of these compounds. What would you like me to do? So now it's asking for my input, and I think that would be I think that is fine. So what we are going to do now is ask it for the list. So please create a report with the RN name, Inchi, and the number of references. Oops. References in CA Plus for those 486 compounds. Okay. We have those taken care of, and let's submit that request, and yeah, hopefully it can create my report. You may see this command here as well. An error has occurred. Please try again in a few minutes.
That means that the internal LLM on which CS Newton is based has reached its maximum text processing capabilities.
So what we are going to do is we are going to go to the command prompt. I am going to do a new display history to figure out where we are in our search. So here we see that we are at L16 with 486, and what I would be able to do there is perhaps take those compounds to the viewer, or I could display the information here, display RN, the index name. I want to see a molecular formula. I wanted also to see the INCHI key. I think that's INCHI, and then also the ref information. So, and let me just do that for the first 100 in the answer set. Yes, apparently it had gone to CA Plus to do something, but wouldn't be able to provide that. So here we see we have the results, and we could then go to the transcript and create a report for all of this this information. So that is helpful as well. We are going to our next project that is there. So instead of having CS Newton really run searches, still with your overview, etc., you can also just ask it to create a search strategy. So that is helpful as well. And I took the inspiration for this question on one of our previous webinars, which was about searching vegan meat, so artificial or plant-based meat, so to say. So in this case, I could ask it help me build a very comprehensive search hedge of synonyms for imitation vegan meat. And let's get that going and see if this is something that CS Newton could help us with as well, and how it would do that. Here we are. That's already quite quickly. So it is an excellent approach, developing strong vocabulary. So primary terms: vegan meat, plant-based meat, meat alternative, meat substitute, meat analog, meat replacement, mock meat, faux meat, fake meat, etc. So, and then here also protein-focused terms. So it has found that tofu-based, seitan, tempeh, mycoprotein, etc. So it gives us sort of there an option to run that give us a nice way of providing further details in here. Now we do know that STN contains interesting information from thesauri, which would give us a hierarchical approach. So maybe a subsequent question would be, let's check the thesauri in all appropriate STN databases. And appropriate is obviously here in the context of our previous question around a food-related topic. So hopefully it will also search a food-related database for this. It is going to FSTA, Food Science and Technology Abstracts, looks a very good choice. We also see that it will do further searches in Agricola, CABA, and Biosis to see that. And we see that meat substitutes runs a good number of results. It looks at the control term field, which is usually where you have this information, and it then tries to identify additional terms. It should know that you cannot use truncation symbols in the expand command. So it does find that is not an option, and looks at further details there. It goes to Agricola, runs similar approaches there. It sees that Agricola doesn't have a huge amount of thesauri, not a very well developed one. Let's go to CABA, which is short for Commonwealth Agricultural Bureau Abstracts, which includes something like nutritional abstracts, so also a very relevant database. There we do see that we have lots of terms that may be helpful, and it clearly stores what it finds sort of in that review of the control terms fields, and tries to provide further details there. So it has looked at FSTA, has the best controlled vocabulary with plant-based meat and vegan meat. There's some overlap in there. Cell-based meat is distinct. Seitan is not in the thesaurus. So here we see some overviews. What would you like me to do? Run test searches with these terms to see the actual coverage, build multi-database search strategies, check patent databases for food technology terminology, which is related to asking questions in other languages. So for those that master English perfectly but few other languages, my apologies. We're going to change the language interaction here and ask a question in Italian. So here I have the same question. Aiutami a costruire una strategia di ricerca molto esclusiva basta su sinonimi per la carne vegana di immediazione nel database CAS. So basically the same question that I had, help me build a very comprehensive search hedge for synonyms for imitation vegan meat, but this time in the database CA+. So let's see what happens when we ask a question in a language different from English. So I already see results coming back in here. So here we get actually quite an interesting approach. It has actually not produced anything here in the database window, but it has produced a number of steps. Maybe it's asking me, why would you want to do this in CA+? But it has provided me in English, which is helpful, but the context of this is still back in Italian. So it comes up with search strategies for the suggested STN commands, but my context is in Italian. My search strategy certainly is going to be very nicely in English, because that is the language of STN. It wouldn't help if it would suggest me Italian terms that would be there. So here it provides me several search strategies that it had done in various steps, and we would be able to take these into a search strategy. It also provided me with some certain restrictions that would be there. So maybe things that I want to exclude, because there may be some other things that I may not be interested in, like cultured meat or cell-based meat. I don't know, so that is there. It provides me some information about proximity operators, different search fields, and truncation. So I would say basta. This is enough Italian for our session here. And but even if you have I don't know, other languages, Japanese, Chinese, Portuguese, or others, it is able to handle questions in a lot of other languages as well. Let me move to my last example for now, and see if we can do a little bit of a numeric range search. I've tried to do something small because my colleagues will have another short coffee lecture on the numeric properties searching in CS Newton in IP Finder. So here, what is the effect of adding 0.1 to 0.9% of graphene oxide on corrosion resistance of certain materials? So let's have a look. So it's going to CA+. That's okay, and it searched for graphene oxide and corrosion. That gives quite some information. And here it did something tricky. It's going to try and search for kind of all the intervening pieces and looks for weight percentages for that. And it does find something, but this is clearly not ideally going into the right way. And again, it's displaying me some information to see where, I do see that there's relevant information here. Graphene oxide, 0.5 weight percent, leading to remarkable enhanced corrosion resistance. So that certainly looks good, and it gives me an overview of the publication trends, which is fine. And remember, if you don't want this, you can certainly ask it just to produce a search strategy and not to do a more in-depth analysis. But it's also clear that perhaps we may want to see this really as a numeric property search. So here it has, still finds some critical factor, further things that it may do there, but maybe we should give it another nudge. Please run this as a numeric property search where the percentage range is found close to graphene oxide in the broader context of corrosion resistance. And if all is well, it will find out that numeric property searching is not possible in CA+, or at least not yet. We'll continue to provide pressure to our product team to make this happen. But it then goes into the WPI search, and it says that the per property code is what we need. So it also then tries to do CEABA, chemical engineering abstracts. So there it does find the percentage 0.1 to 0.9% with graphene oxide in the same sentence as corrosion. Tries a few different ways of ensuring the distance of those results, and see if that is hopeful that it provides some useful information. Let me see if I could stop this and maybe just ask, please try the NPS search in Compendex. see if that is a possibility to redirect the search to a different database. Yep, it goes to Compendex and basically runs the same search, which gives us 27 results. And yeah, it can provide some interesting observations from that. Here we see that it uses the title abstract quick display. So quick would be keyword in context, where we would see the terms that we searched for appear prominently. And it did indeed find further details. It made some interesting observations out of the text. So that's also helpful to not have to do this manually, to say, okay, what was the concentration, what was the application, what effect of corrosion resistance was there, and what were the key findings. So that's a typical thing that you can request from an agentic AI tool that we're using here. Very good.
So let me also show a project that I ran yesterday, and I think this is also an interesting approach. So looking at the fact that Turkey hosted the CEPIUG meeting earlier, and there is a Turkish Patent Information Society which is very active. I thought let's put Turkey as a little bit in the spotlight. So I wanted to see what are some emerging drug companies in Turkey. So in that way, we wanted to use the Derwent database to find patents in the usual drug area as an IPC or CPC, and that have TR as the priority application country. Mainly interested in companies that didn't have any patents 5 years ago and have multiple patents now. So those are very clear instructions from my needs, not very well indicating kind of what the search strategy is. So when I submitted this, I got indeed a few interesting comments. It first tried to find this in the WP-IDS file, but on this login ID, I do not have access to that file, so it then fell back to the WP index database. It started to run searches there for indeed Turkey as the priority application country and the useful IPC and also CPC codes. So it then came up with a total set of 4,300 documents. It then split sort of that up in the priority year before 2021 and then priority year after 2021. So that was something that it decided to do. It then analyzed the patent assignee fields, looked at the top 50 answers. So here we see how that matches out. So we see some larger companies that are probably perhaps longer in place. We also see that there is companies maybe that are just the inventor names and a number of universities. So when it then looked for the individual organizations, it kind of skipped the universities because I was really interested more in companies. So that is very fine. It picked also a couple of characterizing parts of those names and not necessarily the entire name. So, and then it compared L4, which, if we look at that was the older patents to the number of postings in L5, which is the later filings. It ran a few displays to just get a better sense for what these organizations have filed for. So that gave sort of a little bit more of title information. It ran a few more of those companies just to get a little bit more details. Let me look at the timeline breakdown for these companies. So did an analysis on the priority application year and did a few more. And then it came back with its summary after analyzing the data that it got, and we can see kind of the commands that was being executed. So emerging drug companies in Turkey providing from the World Patents Index database. So here it indicated that this is perhaps not very emerging, although there is a strong trend that the number of applications in present years is vastly larger than the patents that they had before. So that's, I think, very nice. You also see the technology focus, notable inventions. We got a few other organizations, 4 patents before, 24 patents after. A significant growth. What kind of area are they interested in? Mainly hyaluronic acid-based products, etc. Altem, no patents before, 10 patents now, etc. So it did find a good number of these organizations. It also identified some market context, and that way we were able to find now further insights that it got by analyzing this, and it gave us a little bit of a background story on how the search was executed. So could we have done this manually? Probably. Would we have taken a short amount of time? If we look at the timing here, 9:44 is when it ran that search. So that is a timestamp. I would say that it was done in a matter of 3 or 4 minutes, and that was certainly I would say quite a nice accomplishment for an efficiency and looking at a different approach, learning the different types of STN commands, and see how that works. Maybe it's also good to indicate that when you look at my question and where I provided information about 5 years ago, I wasn't very precise. I didn't say, look at the priority application year of the last 5 years or the basic publication year of the last 5 years. And so if you're not very specific in your request, it's going to make kind of a best effort. And since I was talking about priority application countries, it assumed that I also wanted the timing to be the priority application year. So again, make sure you provide good context to your question and be able to not cause for any ambiguity that may be coming up in your request. Let's see if there's some further questions. Thanks.
I have seen that Mike Exler and Rob Austin have been very busy during the demos, and that they have already completed a lot of the answers as well. So many thanks for that. Here on this slide, I have tried to summarize sort of our the key findings from these examples. So please note that broad, ambiguous prompts will produce kind of the best guess of what CS Newton thinks that you mean, but you might have to rephrase that to be more specific. Remember again that if you have a search strategy, then don't start CS Newton thinking it could continue on that basis. It will delete your search and select history at that start. Always good to keep your cursor over the stop button if you want to intervene with that. And same is true for our colleagues abroad that would prefer to interact with CS Newton in other languages than English. Actually, already in SciFinder, where we have CS Newton for a slightly longer time, we see that about a third of the queries that that are being asked are done in a language other than English. An older project cannot be reactivated in a new session. So similar to your transcript on STN, which I cannot just open and continue, it's not a stateless system where I can just bring back my entire search history. So that kind of does not work. Even for your CS Newton sessions in your history, you can display them or you can download them, but you cannot reactivate them. So that would require a significant change in the STN architecture. So this is probably very difficult to accomplish. It is possible to add a manual command to the STN command panel, which is on the bottom right-hand side. So there is a bar there that simply would allow you to start with a particular command, and then you could do all of that information as well. We have all found that setting up upfront boundaries, which databases should be used or which databases should be absolutely avoided, provide favorite evaluation display formats like title hits, really helps a lot. Or even the context to say, I'm a patent examiner trying to determine patentability on this particular topic, really helps the LLM to interpret your question much better. And we did see that there is a maximum amount of text. I did learn that if you try to use, let's say, more than 20 full text patents, it already starts to hit those system limits. So it is not able to analyze massive amount of text at the moment. Good. I want to give the floor a little bit to Mike and Rob to see if there were any noteworthy questions that they would like to comment on, or if I could maybe help answer some of those.
Hi, Paul. I think there was a consistent theme around the current state of Newton being that you cannot resume previous conversations, nor can you set up kind of recurring prompts or alerts through Newton. So there's clearly a lot of potential here around being able to resume them in the future or ask Newton to rerun certain things for you for a degree of consistency and time savings. Do you have any thoughts on that and the direction we might be able to move in to address some of those desires?
Yeah. No, that's yeah, I think something that is high on everyone's wish list. Certainly our CAS IP Finder version of Newton is able to do that because it runs on a stateless system, which allows you to just pick up from many days, weeks, months before. What I have seen as maybe a workaround is the possibility, for instance, you do a substructure search on your structure, you save that answer set, and when you start a project in Newton, you basically start in that right-hand lower end to simply give the activate command to say, activate my saved answer set for this structure search. And you can even ask Newton to say, do you understand what this answer set is? And it will probably come back and say, oh yeah, you've done a substructure search on this query and you found whatever 500 compounds. And then you could continue say, could you help me find the patents that are older than this particular date? And that could help me perhaps invalidate a particular piece of IP. So this might be a workaround to save a particular answer set on STN and then reactivate that in CS Newton to continue at least based on that approach. But I think that is probably the best scenario that we can offer at the moment, because really reactivating the entire session, that is quite a bit into the distant future.
Yeah. We'll look into that as well. Maybe there is some possibility in the future to feed it a previous displayed history or something like that and tell it to rerun those commands. Probably the last item. There's a consistent theme of questions here, kind of around how Newton compares to the manual or traditional approach, how it compares to a professional searcher doing the work, and then also on a related note, how does Newton choose to use this field versus that field? Maybe you could expand a little bit upon that, and then also how this relates to the first bullet point on your screen right now around just ambiguity versus specificity in the prompting.
Yeah. I think this depends very much on where you are in the STN learning curve. If you're a brand new colleague of an IP team, then it is probably good to indicate that, and then Newton is very effective to find kind of the most appropriate search fields. It is not always the best for extremely advanced searchers, but this is also something where I think providing it with even more expert recipes, search strategy recipes from our team and our IP services group can help remedy that particular part. So as with many other AI solutions, always good to verify what it does. Maybe even ask it, why did you come up with this particular area or this approach? So it is very effective in going through the summary sheet, in going through the command documentation and find sort of an approach. If it has guessed something, then that would mean that it would recover from that mistake and look a little bit closer to what does it need to do. We've seen several examples of this where it started on a wrong field and then got 0 answers or got an error message and searched further what the appropriate search term would be.
Thank you, Paul. And I'll just briefly add as well that you, as the user interacting with Newton, you do have the opportunity to provide your own robust set of instructions at the beginning of the conversation. So if you are someone that is enjoying working with AI and you are familiar with the idea of kind of prompt engineering, you certainly have the opportunity to insert at the beginning of the conversation a series of instructions or constraints for how you expect it to perform. So, for example, would you like Newton to verify all of its steps with you before it proceeds, or would you like to direct it to be very comprehensive in its use of field codes or proximity operators? So there is an availability for you to kind of dictate how it behaves as well.
Yeah, no, thanks for that addition, Mike. That is great. I know it's already a little bit over the hour that we have been given, so I do want to respect people's time. We will obviously have more sessions on on CS Newton in CS IP Finder. The next one would be a coffee lecture looking at MPS cases, but this will be featured throughout the next coming weeks and months. And if you have questions, please contact our help desk. And we also would very much like to hear from you. So please take a moment to fill out the survey. So that helps us develop more of these particular sessions. Would like to thank Patricia, would also like to thank Rob and Mike for their hard work with all of your fantastic questions.